Guys, so we got the June 22 paper 2H calculator paper question 18. So the question says PQR and QRS, so PQR and QRS are triangles. Calculate the length of QS. So it wants us to find the length of this. Okay, give your answer correct to 3 significant figures and show all your work in. Alright, so with angle geometry questions like this, it can be, easy to get overwhelmed. Initially you might think trig, but trig only works on right angles. So we'll leave this out. So anything to do with to, we can't use that. You can't use a squared plus b squared equals c squared. That doesn't apply here. There's no right angles here. So all of this is not useful to us. So we've basically got to find a bunch of angles and lengths using the formulas that we know. Unfortunately, the formulas that we need here, they're not in the formula booklet. They rely on sort of our memorization, and those are the sine and cosine rules. It might not be initially obvious like how to use them, but basically just remember the sine and cosine rules. Sine, cosine rules work on any triangle, i.e. not just right angle triangles. Okay, so that works on anything. Now again, we'll break this down bit by bit. So if you're in an exam, you're like, oh, which ones? I know the formulas, but I don't know what to do with them. Just draw it out. Okay, so we start off with sine rule. The sine rule, you commit this to memory. A over sine A equals B sine B equals C over sine C. So we have our triangle here. Yep. Okay. This is angle A. This is angle B. Angle C. This is A. This is B. This is C. So we're saying A over sine A, the angle A, is equal to B over sine B is equal to, C here over sine C. So that's the sine rule. Now the cosine rule. Okay, cosine rule. Now cosine rule is A squared is equal to B squared minus C plus C squared minus 2BC cos A. It's rewritten. It can be written as, you can just rearrange this, cos A to the B squared plus C squared minus A squared 2BC. You'll use this one, you'll use when you want to find the angle. This one you'll use when you want to find the side. Okay, so again, A squared equals B squared plus C squared minus 2 times B times C, that's the length, and then cosine A. So that's what it is. So really, you'll use the cosine rule. So I use this for cosine rule, this for sine rule. You'll use cosine rule when, for example, you'll know, if you know these two, you know this, but you don't know this, then you can use the cosine rule to find that, or vice versa, or one of these three. But you're looking at these three. Okay, sine rule is basically if you know this and you know this, and you know this, but you might not know this one, or vice versa, that's when you use sine rule. So I hope that makes sense. But basically, sine rule you use when you're looking at angles, opposite angles and sides. Cosine rule is basically when you're looking at two sides with an angle in between, like this, or a side and an opposite side, but you're trying to find an angle in an opposite side, but when you want to try to find another side. Okay, I hope this makes sense. But when you draw out like this, you know what you're dealing with. Okay, so if we look at this, our goal is to try and find this length QS. That's what we're trying to find. Alright, so to find that, we need to use these rules. To find QS, so let's just look at this triangle here. Could we use sine rule? Well, if we look at this triangle here, sorry, I'm just looking at this one. Can we use sine rule? Well, not really, because we don't know this side. We don't know any of the sides, so sine rule doesn't work, because you need to know at least one of the sides in order for at least one of the two of the sides and one of the angles in order to find the angle. Or in this case, if you want to find a side, you need to know a side, an angle, and another angle. So you need two angles and a side. We got two angles, but we don't have a side. Okay, let's work here. Here we've got a side, and an angle in between. So immediately this is showing cosine rule to me. Why can't we use sine rule here? Because essentially we want to find out as much as possible about this shape, this sort of weird quadrilateral that's given here. So in order to do that, you need to see what you can use. So sine rule you can't really use, because for example, if you say that's A, that's B, that's B, that's C. A over sine A is A over sine 27 is equal to B, which is 11, over sine B. So right immediately you have this that you don't know and this that you don't know. There's two unknowns. You can't really solve the equation. Okay, I hope that makes sense. So that's why you can't use the sine rule. But what you can use is the cosine rule. So I'm going to put this in a different color so that it's a bit more. Okay. Okay, I think it changes the whole thing. So let me just rewrite the whole thing. So angle A, it's angle B, it's angle C. C to B, that side is equal to A. Alright? So here, when we do our calculation, we can use the cos rule. So A squared, let me do this in a different page. A squared is this, in this case, we're just leaving it as A squared. B is equal to 9.4. C is equal to 11 minus 2, 9.4, 11, cos A, what's the angle A? A is equal to 27. See that here. So that's our triangle. Again, all I've done is I've just replicated this triangle using this format here. Wherever the angle is, the side is the opposite. Angle, side is opposite. Big C, small c, and I've just replicated it. Big C, small c, big B, small b, big A, small a. By the way, it doesn't matter whether you call this B and then you call this C. It's still the same thing. Okay. Alright, so that's that. Cos A is equal to 27. So you plug that into your calculator, and what do you get? So A squared is equal to 9.4 squared plus 11 squared minus 2 times 9.4 times 11 times by cos 27. Okay, you get 25.0999. Just leave it to 3 dp. Just one thing, but by the way, I've stored this. I'm sorry, not stored. It's left in my calculator because I want the exact value. So then I take I square root that number, 5.00997. Okay, just leave out that number. I've kept that in my calculator, so just leave it there. Sorry, that's 998. That's the 5 dp. Okay, so that's equal to A. It's 5.01, let's say. Alright, now we want to find this side. Question is, how do we find it? Well, now we have an angle. So you have an angle, you got a side, you got an angle, and you have an unknown side. Now you can use the sine rule. Okay, so in this case, you can say this is equal to A, this is equal to B, and QS, that length, QS is equal to small b. Sine rule says A over sine A is equal to B over sine B. In this case, our A, 5.01. Again, I've stored the number on the calculator. Over sine 41 is equal to B, which was this B over the sine of that B. Okay, so that's just leave that as B over sine 88. Or actually, to keep it accurate, B is QS. Okay, so we rearrange that to say sine 88 times by 0.00998 all over sine 41 is equal to QS. So our QS is equal to sine 41, just plug it in the calculator. So 5.00998 over sine 41 times by sine 88. By the way, I've kept my 5.00998 as answer in the calculator, just to retain the accurate value. Get 7.63. 632. The question is asked for 3 significant figures, so 7.63 3SF QS. That's the final answer. Okay, guys, just recapping what we've done here. So it says PQR QRS triangles, calculate the length of QS, give your answers correct to 3 significant figures, show all working. So we've identified we need to use the sine or cosine rule simply because there are no right angle triangles in this diagram. So we have just sort of regular triangles, and the only way to find unknowns in a regular triangle is to use either sine rule or cosine rule. Okay, and I suggest, if you're not comfortable with sine rule, cosine rule, in the exam, I know it'll take time, but you'll be more accurate in your answer. Write out the actual rule, write it out fully, and then write out the triangle that represents the rule. Okay, if you do this, you're very unlikely to go wrong. So we've identified our triangle here as A, big A, C, small c, big B, small b, to replicate this triangle here. And we've sort of invoked the cosine rule. So cosine rule says A squared plus B squared equals B squared plus C squared minus 2BC cos A. We've subbed in all the B's, so B is 9.4, C is 11, A is 27. When you sub all of that in, you get A squared is equal to that, so A is equal to this. So now we know A. This is our A now in this triangle, so A is equal to 5.01, we found that here. Now in this triangle we have a side, an angle, another angle, and we want to find this side. This side is unknown, so we got 2 angles one side and the other side is opposite the angle that we know. So the thing to use here is the sine rule. Don't worry if you accidentally wanted to go ahead and do the cosine rule, you wouldn't be able to do it. You'd find that you have too many unknowns, so you'd have to go back to the sine rule. So we use this. It also equals c over sine c, but we don't really need that in this question. So you plug in a, we found that from over here. 41 is the opposite angle to a, so this is a, 41 is the opposite. QS is equal to this line here, QS, over sine 88. The opposite angle to QS is this. You simplify it down and try to find out what QS is, and you get your answer here. So that's how to answer this sine cosine question in the calculator paper for June 2022. Let me know if you have any questions. Thank you.